Can you please type down in the comment box you are ready? So we will start the session now. Are you ready, my dear friend? Yes or no? Type करो यार comment box में. Sir, traversing an array does have any time complexity? Of course, it has time complexity, the theta of n. If I haven't told you this, then please mark it down. Traversing in the array takes theta of n time. Ready, 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 ready. Okay, great. Then let's start the session now. So, first of all, insertion in the array. Insertion in the array can happen two ways. The first way is always if you are inserting an element at the last, so wherever the current element is present, on its next index you are inserting another element. Or sometimes insertion is based on the index, means wherever you want to insert a new element, for that element you will have to provide the index कि सर इस index पे जाके ही insertion करना है. You will have to go to that index and you will have to insert. Now you will ask a question, sir, in this method, if you are asking us that index will be provided on that index only in the array, the new element to be inserted, then if already one element is present there, then we will have to shift all these elements so that that given index becomes free, and on that element, that index, the new element is inserted. ज़्यादा समझ नहीं आया? You did not get it? No problem. I will explain with some examples and with more appropriate explanation. Let's start with the first one. If you are inserting an element in the end of the array. So first of all, I have brought some array for you. So this is the array. Let's say starting index is 0 for the convenience. Let's see, this is index 0, index 1, index 2, index 3, wait, 2, 3 and 4. Now suppose if I am saying very simple thing, if this is the array currently, what is current lower bound where the element is present? Current lower bound for the element is 0. Current upper bound for the element where the last element is present. On which index last element is present? 4. How many number of elements are there? 5. Is that fine? Now if you want to insert another element, what you will be getting in the insertion algorithm? Insert in the array A. So array A will be given, comma, an element will be given, let's say some x, or let's say in some variable item they have given. अभी क्या करने का है? अभी क्या करने का है? अभी क्या करने का है? It's very simple. It is very, very simple. Look at this. What should I do? I will have to check out. I'll have to check out if suppose I am having total index in the array 5, 6, 7, 8 and 9. The last index of array is 9. That is my upper bound of the actual upper bound of the declared array. I'll have to check if my this upper bound has reached to this max limit. I'll have to check if this upper bound has reached, this one has reached to the max limit. Max limit means that index which is my last index, this one, max limit. If this upper bound has reached here, then it's like array is full. अभी और नया insertion नहीं कर सकते. Right? Now, what happens? Now what happens? Look at this, look at this. What happens in that particular case? I can say overflow. So it will be returning overflow and then we will return from the algorithm. Done. We cannot perform insertion. If suppose we can perform insertion, means this condition is false, what exactly I will do? On this index I'll have to insert new element. Yes. Upper bound is here. Yes. So which index it is? Upper bound plus 1. So what exactly I'll do? In the array on index upper bound plus 1, I will insert what? The element. Which one? This item, whichever is given in the algorithm. Right? After that, what I'll have to do? After that, I'll have to do this upper bound plus plus. So upper bound comes here and then I'll have to do this also, n plus plus number of elements will also increase if I'm maintaining this. That's it. That's it. बस खत्म हो गया. Yes, खत्म हो गया. Yes. What is the complexity? What is the complexity? If suppose I am having 5 elements, then to these 4 statements I'll have to run, and if I will have 500 elements also in the array, and if I have empty space, how much 4 statements I'll have to run? Yes, means in this case the complexity, the time complexity, the runtime complexity will be independent of your number of elements, and that is how, or that is where we write the complexity constant. What we write? Constant. So here in this particular case the time complexity will be constant. Why? Just because at the end we are inserting the element. That's it. Here we will insert the element, we will update upper bound and n. That's it. Nothing else. No dependent on how many number of elements are there. Not at all dependent. So time complexity will be constant. You can write it as theta of 1 or big of 1. Whatever you want you can write. Both are same to same. Both are same to same. Constant complexity. Asmita, Sneha, good. Good work dears. Good work student. Good work. Good work. चलो आगे बढ़ते हैं, आगे बढ़ते हैं. ये देखो another thing. Now insertion in the array based on index. If we are inserting an element in the array based on index, which index I can provide for insertion? Suppose this is the array starting from, let's say, lower bound, right? Last element is present on upper bound. Which index I can provide where the element can be inserted? Can I insert another element here on upper bound plus 1? Yes, I can. Right now, मैंने बताया ना ये. Can I insert the element here directly without inserting here? No. Why? If you remember the first quality, the first characteristics of the array, all the elements of the array should be on consecutive locations. तो ऐसा नहीं हो सकता. क्या नहीं हो सकता? कि यहाँ पे एलिमेंट ना हो and यहाँ हो. It is not possible that you don't have any element here and we have element here. Not at all possible. So new insertion can be where? कहाँ नया इंसर्शन कर सकते हैं? We can do insertion from lower bound to upper bound plus 1. Any index can be. Right. So what I am saying is very simple, very simple. In this case, based on index, in the insertion algorithm, what I will be getting, of course, array, of course the item to insert, and I will be getting I is what? I is the index where the element should be inserted. Index at which new element to be inserted. Right? Now you will have to tell me that this index can be what? This index value can be between lower bound. Yes, I can insert here. Yes, here, next, upper bound. Yes, upper bound plus 1. Yes, up to upper bound plus 1. Between these values, any value you can give, and on that I will be inserting new element, no problem. Akshay Kumar, just watch the very first video of this particular playlist. You will be able to understand how to calculate complexities. How do we get this upper bound at present? See, when we have or when we maintain array, we are maintaining upper bound and lower bound also. So along with the array, you can either pass upper bound, lower bound also, or you can keep upper bound, lower bound as the the public parameter, or I should say global parameter, so that you can access those upper bound, lower bound easily. So understood this particular equation, why this condition? क्योंकि we don't want to have one index where the element is not present and here the element is present. Array elements should always be in consecutive locations. Fine. Chaliye. Now let's see different cases. Case number one. Let me see case number one. You will understand using these different cases how exactly insertion happens. So right now these are the elements. These are the indexes in my array. Given like this means lower bound is at index 0, upper bound at index which one? 4. Total number of elements right now 5. And suppose case number 1 says I given as index 5. Is it possible to insert another element at index 5? Yes. If I is equal to 5, there is no any problem I do have. कोई प्रॉब्लम नहीं है. Whatever the element x y z, whatever the item given, I can insert here directly. No any tension at all. No any tension at all. Right? Now listen. If I do have case number 2, okay, I will go back. Don't worry. Don't worry. I will go back. I will explain it. I will explain it even more detail. सब कुछ सुनो तो सही. सब कुछ सुनो तो सही. Look at this. Look at this. These are the indexes, same to same, upper bound, lower bound, n value. Suppose now if I say I index I have given is equal to 2, what happens in that case? What happens in that particular case? At index number 2, here I'll have to insert item. Let's say item is equal to character x. What happens? I will have to make this free. But if I'll have to make this free, I'll have to shift it. But we do have consecutive elements C, D and E. These elements all I'll have to shift one position towards right so that I can make space here for new element X. क्या करना पड़ेगा मुझे? I'll have to shift these elements right side so that index 2 can become free. Oops. Really sorry. Excuse me. Okay, so what I'm saying here is that you shift the element E here, then element D here, then element C here. Index number 2 free. Yes, now insert X here. Got it? Understood that? I am just explaining what to do. I am not explaining how to do algorithmically. मैंने अभी नहीं बताया है कि कैसे करेंगे algorithmically. बताऊंगा, रुको तो सही. In this one, there was no any need of shifting. You know why? You know why? Just because I was shifting I was inserting the element at the end where the empty space is present. Here I am inserting the element at some middle index. So what I'll have to do, I'll have to shift from middle index wherever the index I is given, from there to the upper bound. All the elements should be shifted right side one position so that index I becomes free, and now I can insert X over there. One more example I'm gonna take. Let's say if index is given as the lower bound only. If index I is given as lower bound only 0, in that case what I will have to do, I will have to shift all the elements in the right, all the elements. So E will be shifted here, D will be shifted here, C will be shifted here, B shifted, yes, A shifted, yes, and then after that I'll have to insert, let's say, item X. So here, is there any shifting needed? No. Case 1, when I equals to 5, I should say more generalized manner means I is equal to upper bound plus 1. If the index I given as upper bound plus 1, the largest possible value, I will say no shifting required. No shifting of elements required. right? Here, if I'm saying you need to insert element somewhere in the middle, it's not upper bound, it's not lower bound, means I am having I which is not equal to even lower bound, not equals to even upper bound. In that particular case, some elements shifted towards right, some elements shifted towards right. I hope you guys are understanding this. मुझे उम्मीद है कि आप लोगों को ये चीज समझ में आ रही होगी. Right? Now listen this. Here, if I value is the smallest possible value of lower bound, if I is given as lower bound, in that particular case I'll have to shift all the element. Look at this, A shifted, B shifted, C shifted, D shifted, E shifted. After that you could insert element. Why? Just because I had to insert the first element or the new element on the very first position, so I'll have to shift all the elements. I equals to lower bound, yes, in that case all elements, सारा का सारा element, all the elements are shifted. Which side shifted? Which side shifted? All the elements are shifted towards right. Right? Got it? Understood? Fine. Now listen, बहुत इजी सी मेथड है. एक छोटा सा एग्जाम्पल मैं आपके सामने लूंगा, आपको सब समझ में आएगा. लुक एट दिस असेंबली लाइन. आपको अपने फिजिकल क्लासेस याद है? फिजिकल क्लासेस इन द सेंस आपके स्कूल में पीटी क्लासेस. In the school you have PT classes, yes. So suppose all students have arranged like this way in the single line. Okay, now further one person comes little late because of some reason. That student and the teacher, PT teacher, says that stand at the end. If that fellow will be standing at the end here, anybody will move from its place? No. Any other fellow will move from their place? No. This fellow inserted himself or herself at the end of the queue? Yes. At the end of that line? Yes. No any problem? No. Fine. Other example. Suppose if educator or if teacher, PT teacher says that based on your height, you insert yourself here. You stand here. Now you remember that one hand rule, right? You will have to stand one hand behind, one hand distant, right? Like this way. Right? So if new person should stand here, then what happens? All the behind fellows will have to go one step back. All the behind fellows should go one step back, right? Exactly, we did the same way. If one person comes in the middle X here, then C, D, E all will go behind one step. And if suppose PT teacher says that the new person should insert himself at the starting front, then in that case I'll have to have all the students going backside one step. So different cases we have. Maybe a new person coming at the end of the line, maybe the new person coming at the middle of the line, maybe the new person coming at the front of the line. Based on that I can say how many members will move backside one step or how many shifting we will do. If we are inserting at the end, no shifting. If we are inserting at the middle, some number of element shifting. If we are inserting at the starting, all element shifting. Got it? Now let me go for runtime complexity of this one. But before we go for runtime complexity of this one, what exactly based on index insertion will be giving us runtime complexity, we need to understand the algorithm. Let me write down the algorithm very quickly. Jaldi se. some of the problems only I'll be writing the algorithm for, just because I just wanted to give you the glimpse of the problem with that algorithm. If not needed the algorithm, I will not give, just because in the GATE exam they will not ask you to write the algorithm, or they will not ask question based on कि ये है algorithm, अब बताओ क्या करना है. Wherever they will be asking the questions about the algorithm, I will be giving you the algorithms also. Right? Okay, so before we go for runtime complexity analysis, let me write down the insertion algorithm. So let's say insertion in the array based on the index. Array A is given, fine. The item is given, fine. And I variable are also given. Index I is given. Let's say I have checked already that I is in between these. I is following this particular, I have already checked. So I is following this particular, condition, that it is lesser than upper bound plus 1, and it is greater than or equal to lower bound. Fine. Now if I'll have to insert, what I will have to check, if it is an overflow or not. It is an overflow or not. So I'll check if upper bound has reached to the max limit, then it's overflow. Max limit, then I will say overflow and return. If suppose it's not overflow, then what we will have to do, we will have to check for shifting. So from where to where I'll have to shift the elements. Look at this. I have first shifted the upper bound element to the upper bound plus 1. Then next previous index element to this one. Then this index element to this one. From upper bound, I will have to start shifting the elements towards right, up to what position? Up to index I, wherever the I is present. So what I will write the algorithm is the loop. I will write a for loop. For loop in index K starts from upper bound. It goes up to index I also, you can write here. K when greater than or equal to I, till that time you keep going. K minus minus, inside it I am writing shift the element from index K to K plus 1. Index K plus 1 in the array will have element at index K. Keep shifting, keep shifting, keep shifting. Now, look at this. If this is fine, all the shifting done, yes, at the end what I will do, I will write down in the array at index I will insert the element, which one? Item. That's it. Done. Fine. और भी कुछ लिखना पड़ेगा? Yes, upper bound plus plus. Inserted element, yes, so upper bound increases, yes, in fact n plus plus also. Number of elements also will increase. Number of elements also will increase. Now, see, the thing is, algorithm analysis we will do. Two ways I can do the algorithm analysis. There are two ways I can do algorithm ka analysis. One way is by just looking at the method I can understand what should be the algorithm ka complexity. Or if not, then I can check out the algorithm and still I can understand that what should be the algorithm ka complexity. Fine, check. First of all, I will explain you using this algorithm. After that, I will go back without even having the algorithm also. We can understand if this is the approach, what should be the complexity. मैं दोनों तरफ से बताऊंगा. Don't worry. बिल्कुल दोनों तरफ से बताएंगे रे बाबा. चलो रुको तो सही. शांति. चलिए. Now look at this. This statement, constant time. This particular loop runs for how much time? Oh, one thing this particular loop runs for how much time? This loop runs for shifting. So it depends that how many elements I'll have to shift. Suppose if I am checking out case number 1 where I is given as upper bound plus 1. When I is equal to upper bound plus 1, look at this, k equals to upper bound, fine. K greater than equal to I. K greater than equal to when I is equal to upper bound plus 1. Upper bound greater than equal to upper bound plus 1, no, false. So there is no any shifting. Yes, in the case 1 we don't have any shifting. We don't have any shifting. We don't have any shifting. Yes, understood. Now listen, what am I saying? It's very simple. When there is no any shifting, this particular loop runs 0 times. Only one statement checking, condition false, we come out, and only insertion. Now look at this. If suppose you have I some middle value, then how many times this loop runs? For how many elements you are shifting, right? So this particular loop will define my complexity. Why? Just because this is the constant operation, but if this loop runs for larger time, then the complexity will be larger. If loop runs not at all, then constant time complexity, right? So how many times the loop runs, that is dependent on I. If I is some middle value like this, the number of shiftings, the loop runs for some more time. If I am having case number 3, that is the worst case, when I will have to shift all the elements. When I'll have to shift all the elements, all n elements, yes, all n elements. In that case, loop runs n times. So what should be the complexity? The runtime complexity I will be writing big O of n. अब आप बोलोगे sir, why not theta of n? Just because big O of n means I may have. Very good evening and very welcome to all of you. अगर आपने ये सेशन लाइक नहीं किया तो प्लीज लाइक कर दो यार. इफ यू आर एंजॉइंग द सेशन को लाइक कर दो. चलो बढ़ते हैं आगे. So what am I saying is big O of n. Why? Just because the number of times this loop runs is not fixed, that it will always run n times. It will always run n times? No, it may run n times, it may run less than n times, it may not even run, right? तो इसलिए हमने complexity लिखा big O of n. Big O of n. Maximum shifting is n. Yes, exactly. Maximum shifting will be equal to n, but it is possible that we may have less number of shifting than n. It is possible that we don't have any shifting. So in that case, big O of n will justify our algorithm ka complexity in the best way. Right. Understood this. So what I'm saying is maximum times the shifting will be done n times. That's it. Not always. That's why big O of n time. You can check it out here also. The complexity, how you will define. Sir, case अगर यहाँ पे if we have upper bound plus 1 as I value, no shifting at all. So best case constant time complexity. But if we have some intermediate value, some shifting will be done. If we have first value, lower bound value as I, then all elements I'll have to shift. In that case, the complexity will be n. N element shifting, I'll have to perform n operation. Yes, one shifting, one operation. In that case, complexity will become n. But big O of n, not theta of n. Why? Just because every time you are not performing n number of operation. If every time you will perform n number of operations, theta of n complexity. If you say maximum n number of operations, sometimes less than that, sometimes even one operation also, then big O of n complexity. I hope everybody is clear about this. Jaldi se confirm kar do. Everybody clear about this? Yes, no. Clear, yes, no. Then we will go for deletion. Now this deletion we can do quickly as soon as possible. Why? Just because you guys are aware of insertion now. You guys are aware of insertion now, right or wrong? Yes. Now deletion, exactly same thing. If you are deleting the element, you can do deletion from two different perspectives. First one is always delete the last element. Second one is based on the given index. Same to same as insertion, deletion भी दो टाइप से हो सकता है. Right? Got it. Chalo. So let's say, suppose we want to delete always element from the end. It's very simple. It's very simple. If you want to delete this element, delete it. After deletion, what you need to do is just upper bound minus. That's it. And n minus. Once you do this, deletion done. एक बार किया, डिलीशन डन, और कुछ नहीं बचा. But if you are going for the deletion at the end, this one you will have to first check ki is there any problem with the deletion. What you need to check is if we have element n greater than 0, then only deletion is possible. If yes, then only deletion is possible, otherwise not. Right, so what you will check, if n is equal to 0 means what condition it will give you. अगर आपके पास नंबर ऑफ एलिमेंट 0 हो गए तो क्या कंडीशन होगी? What will be the error when you don't have elements and you try to delete the element? Don't say sir एग्जाम सिचुएशन के दिमाग में कुछ नहीं और बाहर निकालने की कोशिश कर रहे हैं. It's called as error. What is अंडरफ्लो? क्या बात है, अरे वाह. Right, okay, fine. So let's talk about this then. Let's talk about the second one now, that is deletion based on the index. If suppose array is given from lower bound to some upper bound and deletion is asked, right? Deletion is asked, what element can you delete? Can you delete element here present on upper bound plus 1 or this one or this one or this one, this one? No. Why? अरे यार एलिमेंट तो यहीं से यहीं तक प्रेजेंट है, इसको थोड़ी डिलीट कर देंगे. We have elements from lower bound to upper bound only. So the deletion should be done between lower bound to upper bound only. So if index based deletion is to happen, I index is given, I index is that index from where the element to be deleted then it should be between which to which value, between which to which value. I should be lesser than or equal to lower bound and greater than equal to lower bound, lesser than equal to upper bound, right? So for your deletion algorithm, what will be given to you? For your deletion algorithm, you will be having of course array जहां से डिलीट करना है and an index I. Fine. चल अब case number 1, very easy case. Case number 1 says that I value given is equal to upper bound. What should I do in this case? What should I do in this case? That if I value is upper bound, should I have any kind of trouble? No. I'll have to delete this element. Fine. So right now indexes are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. 5, 6, 7, 8 and 9. I'll have to delete this particular element. In that particular case, what should I do? I'll have to just do one thing, which is upper bound minus minus and n minus minus. बस. That's it. Why? सबसे last वाला element जो delete कर रहे हैं, we are deleting the very last element. So I don't have any problem. हटा दो. Suppose there is a guy in your PT class line, that particular fellow is on the last position and the teacher wants that fellow should come to the front here so that fellow can do this and you all can follow him or her. It may be very exciting for you to come in the front on the front desk or on the front line, or it may be very embarrassing for you, whatever the situation is. But if you are removed from the last, nothing changes. All the elements should be on their own position. Now, if suppose case number 2, suppose I have given I is equal to 2, some intermediate value, this, what should happen? What should happen here? In this particular case, I'll have to delete the element at index 2, which is C. So if C is deleted, I can't keep D and E here, and I cannot keep this particular space empty. What should I do? I'll have to shift. Suppose from the line, if one middle person is removed, other persons who are following that fellow should move one step ahead. So in this case, what I'll have to do is C will be replaced by D and E will be coming here, and upper bound will be coming up to this level only. That's it. So that I can have element A, B, D, E on the sequence 0, 1, 2, 3 indexes. Right? And suppose if I am having case number 3, in that case, if I have given I is equal to 0, which is nothing but lower bound. अब अगर if we are passing the I value as lower bound, what happens in this case? In this case, I will have to shift all elements. No, I'll have to shift n minus 1 elements. Why? A is to be deleted, yes. So this I am not shifting anywhere. B I will shift here. Then C I will shift here. Then D I will shift here. And E I will shift here. So here will be lower bound. Still upper bound will be here. And elements are B, C, D, E on the sequence 0, 1, 2, 3 indexes. Right? So in this particular case, maximum number of elements shifted. Which side? Which side shifted? Towards left or right? Left. One position in the left. And how many maximum number of elements? If n number of elements total we had, then n minus 1 element shifted. In this case, when we were having insertion and worst case, all elements, means all n elements were shifted towards right, so that you can make space here. There is no any element missing for shifting. Here only n minus 1 element shifted. Why? पहले element को कहाँ shift करने जाओगे उससे? तो delete कर दिया. The first element is deleted. Yes, deleted. So maximum number of elements shifted towards left, n minus 1. Here some number of elements shifted towards left. Yes. Some elements shifted left side. And here, any element shifted? No, no shifting. Oh. No shifting of elements required. So here, in this case, I is equal to upper bound. Here, I is not upper bound or lower bound. I is lesser than upper bound but greater than lower bound. And here, I is equal to lower bound. Let's quickly do the runtime analysis of this particular situation. And after that, I will talk about that where you can use these two types of insertion deletion, that we should use the insertion at the end and deletion at the end only, or we should use the index based insertion deletion. Okay, let's see. Runtime complexity analysis. So let's quickly write the algorithm first and we will understand. Actually, you already calculated the complexity. You can only let me know what is the runtime complexity. It is exactly same as insertion. It is exactly same as insertion. Do you have any free lectures on Unacademy Learner app? Yes, Shivans. Yes, I am having 9 AM daily classes of operating system on Unacademy Learner app. Daily. Yes. right? Okay, now look at this runtime complexity. So first of all, let's see the algorithm. So for the algorithm deletion, delete, right? For deletion algorithm, we are getting first of all array A, and then we are getting index I where the deletion should happen. Fine. In this algorithm, the very first thing we are going to check is the underflow. So either you can do one thing, like what you can do easily, that if n is equal to 0, all elements gone. Yes, so you can say, you can print underflow or something, or you can just say it's an underflow situation and you can return from the algorithm. If it's not underflow, then what we're gonna do is we're gonna shift the elements. Now look at this, how the shifting will happen. We will start from index I. No, index I element to delete karna hai. So index I pe I plus 1 element comes. I plus 1 element comes. Yes, so let's say we will write a loop for k is equal to I, k less than upper bound k plus plus. So what I will do, look at this, I will shift this element, no, but I will shift next index element here. So if right now k is here, what I will do is k plus 1 index array element should be copied to index k, then k plus plus k comes here, then after that here this element will be shifted here, k comes here, this element shifted here, k comes here, this element shifted here. That's it. Should k value be equal to upper bound? Not needed. Why? Next element to hai hi nahi, right? So what I am doing is I will run the loop till k less than what? Less than upper bound. Okay, I am removing all these unnecessary things. Fine. So what I am doing is k equals to I, k less than upper bound. What I will write under the loop, in the array at index k, I am copying the content from k plus 1. That's it. After the shifting, should I do any other changes? Yes, I will have to do what? I'll have to decrease the value of upper bound, and I'll have to decrement the value of n, also number of elements lesser than 1 than the previous one. Fine. Okay, got it. Now how many times this particular loop runs? How many times this particular loop runs? This particular loop runs maximum n times. How many times? Maximum n times. The loop runs maximum n times, and based on that the complexity will be equal to how much? Big O of n. Big O of n. Why big O of n? Just because the loop runs maximum n times. Not always n times. Not always n times. All the members who are inquiring about my special classes, you can go to my profile. I am taking 9 AM operating system, and 3:30 PM I am taking the pipeline of COA. Yes, I have started one of the most important topic, pipeline processing, that I have started today only. One lecture already gone. 3:30 PM tomorrow onwards I will be live on Unacademy special classes, and you can attend the classes over there. Absolutely free. Yes, absolutely free. You can check out the classes over there. Got it? Okay, okay. So if you got it, then let's solve one question. Let's solve this particular question. So if you are not aware of this particular new thing, I will be asking 1, 2, 3 quizzes at the end of the class always, so that you guys will be aligned that what you have learned exactly, right? So it will be good for you always. It will be good for you ki what you have learned today, you are able to understand and you are able to solve one or two quiz based on it. So solve this particular question, give me the answer. What is the answer? Number of shifting of elements to insert a new element at starting index in an array of 100 elements is. Starting index, if you are inserting a new element at starting index, then the total number of shifting will be all number, all. Answer will be equal to n, which is 100. नितिन रमेश सर का क्लासेस इसलिए नहीं चल रहा है क्योंकि ही इज इन सम पर्सनल ट्रबल्स, he is having some personal emergencies. Because of that he is not taking classes. Some medical emergencies are there. As soon as he'll be free, he'll be taking the classes. Rahul Raj, it is really impossible here to explain each and every statement. I'll go line by line just because here we are preparing for GATE, not preparing for some semester exam. If you are expecting me to explain you every single line and every single statement slowly, I will bring one semester exam sessions separately. For semester exams I'll be teaching you data structures only for semesters. In that case I will explain you the algorithms also, how to write those algorithms and how those algorithms are running. Everything I will explain. Fine. Okay, now answer, you got it. Now let me explain you where these two methods are used. Where these two methods are used. So if you want to have so many insertions and deletions, if so many insertions and deletions are there, then you will always use what? Insertion and deletion at the end. Insertion and deletion at the end. If you can prefer, you should prefer insertion and deletion at the end. Why? If you are inserting and deleting the elements at the end, the complexity required is constant. Runtime complexity is how much? Constant. Here also you can see deletion at the end, runtime complexity is constant. Here insertion at the end, look at this, runtime complexity is constant. So if you have so many insertion and deletion in your application in the array, then you can prefer. I cannot say you will always have to have. No, you will have to prefer, you can prefer insertion and deletion at the end so that you can have complexity very less, constant time complexity. But now the thing is, if you have insertion and deletion based on some pattern like insertion and deletion in the sorted array, insertion and deletion in sorted array. Now the array is sorted, you cannot insert a new element at the end, or you cannot delete the element based on just last element deleted, something, right? So in that particular case, if you want to maintain the array sorted and you will have to insert a new element or you will have to delete the new element or some element, then in that case you cannot do this one, you cannot prefer this one, right? So if you have so many insertion and deletion, you may go for this insertion deletion at the end preferably. If you have some pattern in the array, no, you will have to insert the element based on this pattern only, then in that case you will have to use the other method based on the index or something, right? Sure. Now second question, Quiz number 2 of the day. Number of shifting of the elements to delete an element, I should say, delete an element at from starting index in the array. No, Rahul, as of now nothing here on this channel. There is no any semester course here for you for data structure and algorithm. Once the semester course will come, I will notify you all. So number of elements to be shifted when the starting index element to be deleted, answer should be oh ho, kya baat hai, kya baat hai, kya baat hai, wow, 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 shandar, shandar, amazing, 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 great, super, super. N minus 1, answer is 100 minus 1, 99. These were very easy question. We have one more question which is actual gate type question. Actual gate type question. Ankit, mostly from Wednesday. Mostly from Wednesday. Another quiz I am having for you. You will have to answer for this one. All the members who want to learn operating system in more detail in Hindi, I have started operating system 9 a.m. onwards. The link is already there in your comment box. You just open it. In the link is there pinned up in your comment box. Open it and click on notify me. If you are the first time learner on Unacademy app, then use my code VDEEP10 to unlock the free class. It is absolutely free class. And apart from that, you are having one more class under my profile only. You will be getting pipeline processing. I have started today, and tomorrow onwards it will be 3:30 p.m. daily. Special classes, yes. Sir, will continue DBMS class today? No, it will be from Wednesday. I am waiting for your answer for this question. You will have to solve this question. So I will bring these kind of quizzes daily now. At the end, once whatever you have learned, we will be having such kind of quizzes daily. Consider an array A of n elements, n greater than 1, at least 2 elements should be there. In this array A, n insertions and n deletions are performed in arbitrary order. What should be the best case and worst case complexity of all operations on array? Let's say if you are performing insertion and deletion and you want to have best case. If you want to have best case, then for one insertion complexity is constant, for one deletion complexity is constant. So one insertion complexity constant, for one deletion constant complexity. You are performing how many n insertions and n deletions. Total how many operations? Total 2n number of operations. Total 2n operations. If you are performing total 2n operations and each takes constant time, total time is constant plus constant plus constant plus constant 2n times, the complexity will become big O of 2n, which is nothing but big O of n. In the best case. In the best case also you cannot have constant complexity, Babu. It is like not a single operation now. You will have to perform n number of operation. This is GATE exam. Right? That is why you will have to perform n operations. Why? Just because you are performing n insertion and n deletion, and for all operation the complexities are asked. So for best case, complexity is big O of n. Worst case, let's say I'll have to insert each and every element at the first index only. Means all operations will take n time. In the worst case, each operation each operation will take how much time? Each one operation will take time big O of n. In that case, for 2n operations, how much complexity is needed? For 2n operations, how much complexity is needed? 2n into n, which is n is square. No, Rahul Raj, there is no any currently course which can give you step by step how to run an algorithm. There is no any course. This is very basic thing which every computer science engineer should know. If not, then you should learn first the programming basics. There you will learn it. After that, you can learn the detailed courses. Right? So answer will be C. Big O of n and big O of n square. So such kind of questions, if you will be solving more, of course your learning and understanding will be more, and in that particular case, of course, in the exam you will be performing better. So always we tell you that whatever you learn, if direct kind of question like this way or this way comes, you are like, sir, Hapunich Bhagwan hai, I am the god, I can do anything. But if such kind of question comes, most of the students will not be able to understand what to do, and that is what the GATE exam is. That's why we always urge you to go for one thing. Once you understand one particular topic and you learn it, go for more and more practice questions which